Hello, everyone. My name is Robert Ronan. I am a principal product manager here with the the developer adoption team. Thank you for attending today's webcast, and thank you to Tara Van Cleve for putting all this together. We have an amazing presentation today from the Genymotion team. We have Eleanor Kwok, pre-sales engineer, and Thomas Carpentier, QA manager, both from Genymotion. And with that, let's get started. So before I hand it off to the Genymotion team, I have a few slides of my own. I would like to talk about our new Ampere A1 Arm OCI compute shapes. So the A1 compute platform provides predictable performance, deterministic performance with a single threaded core design. It's improved security by removing core sharing. Everything is dedicated in terms of core to cache ratio. And it's a secure architecture overall with the best price performance in the market. Price performance is about 1 cent per core per hour. And it's available with up to 160 cores or OCPUs per bare metal platform, 1 terabyte of memory, 250 gigabits per second networking. And we have flexible VM shapes that can be sized anywhere from 1 to 80 OCPUs or cores. Oracle Cloud Infrastructure offers Ampere Ultra processors and the industry's first 80-core ARM server. And again, that's priced at just 1 cent per core hour. Bare metal server configurations are up to 160 cores in a single configuration with flexible compute shapes of 1 to 80 cores and with flexible memory configuration of 1 to 64 gigs of memory per core. All this is based on ARM Neoverse N1 core V8 architecture, and all cores are capable of running the maximum frequency of 3 gigahertz consistently. This removes, or it doesn't have any sort of turbo or burst capability. Every core can run simultaneously at 3 gigahertz. Every core has dedicated cache per OCPU and a support up to 1 terabyte of RAM per socket. So what do dedicated resources per core provide? It's better isolation and eliminates CPU contention. This is also known as a noisy neighbor. So because every core is independent in the sense that every core has its own L1 and L2 cache that are dedicated, this architecture allows for or it lowers one's risk to side channel attacks. I would also like to mention, since performance is predictable, it simplifies the economics due to linear scaling. We've done some testing, and I'd like to just sort of highlight the superiority of the Ampere Ultra core versus some of the other architectures that are in the market today. We tested with Nginx, a reverse proxy with no authorization, and Nginx API gateway, again with no authorization. And we saw a 32% increase over AMD Milan and with 16 hardware threads, which are essentially 16 cores running simultaneously. And then we saw 33% over AMD with Nginx with API gateway. Again, 16 threads running simultaneously. Great for all general purpose workloads. Ideal for web apps, database analytics, anything that's HPC based, in-memory cache, specifically ideal for mobile compute or mobile development, which is what we're going to discuss today, and media transcoding. So if you want to get started with Ampere A1 compute shapes on OCI, it just takes a few clicks in order to start with a developer image. Get you started quickly. Everything is pre-configured and ready to go, and you can deploy this into any OCI tenancy. We have tutorials and jump starts for common workloads, reference architectures, tutorials, demos, all to make it easy based on real workloads that people are using today. And we also created an extensible partner-based ecosystem that supports a wide variety of tooling that you're probably already using in your tenancy as of today. So in short, we made it easy. We have a ARM developer portal with resources, tutorials, and a community that will go through all the resources and places to go in order to get up and running. You can also sign up for a free tier account for OCI. This is the first step. These are some of the partners that we partnered with, GitLab, Jenkins, and a couple others to accelerate the ARM ecosystem. ARM processors have grown from mobile devices to servers in the cloud over the course of the last 5 to 6 years, and we provide the tooling and the platform for developers to transition, build, and run ARM-based workloads. So to get started with no risk, we offer an always free services. These are 20+ services that are in our free tier. We're always adding more capabilities into the free tier. And this is free tier for an unlimited amount of time. Within that free tier, we have an Ampere A1 Compute shape with 4 OCPUs and 24 gigs of memory. In addition to the free tier, you can sign up for $300 in free cloud credits as part of a 30-day trial. This will allow you or give you access to all services, just not the 20+ free services that are in the free tier, ideal for developers, students, and just anyone who wants to get started with OCI today. And then beyond the free tier, we started an ARM accelerator. So in addition to the always free services and free tier and $300 in free credits that you get with the trial, you can sign up for the ARM accelerator, and that will give you 365 days of access to free access to ARM compute resources, ideal for research universities, any sort of research project, or anyone who wants to contribute back to the ARM ecosystem. And with that, I'd like to hand it off to Genymotion.
So thank you. Thanks a lot, Robert, for the introduction to the ARM servers on Oracle Cloud. And so, yeah, Thomas, if you can go to the next slide, please. Yeah, perfect. So let's have a look at today's agenda. We will first give a bit of context on why having a good strategy for automating mobile tests is important. Then we will see that this strategy will depend on the tools you use. And with all these tools, you will know how to reduce your testing time and test at scale by prioritizing your test. And finally, Thomas will give you a demo to see all this in action. So let's start with a bit of context on why we think that running tests on ARM emulators for testing Android application is the future. And you will also see why having a good strategy for automating tests is important. So when developing and testing daily on Android, QA and development engineers use emulators. And I'm sure that if you are already in this field of expertise, you may already have faced many challenges and are looking for a solution. Currently, most of the computers are x86 based, so Android emulation solutions need to adapt to this type of architecture. And this architecture is completely different from the ARM architecture of a real mobile device. So we are going to have a bit of history regarding the development of Android emulators. So it gets back to more than 10 years ago when the first Google emulator was released. It was ARM-based, but it was really slow to boot as it was running on x86-based computers. So that's how x86 emulators like Genymotion started to roll out for quick boot and better. But gaining performance comes with a price. Not all mobile application is compatible. Engineers are facing issues when developing and testing native code. The application can be installed without extra configuration on those emulators. And if you are already in Android development, you may have already used an officially supported ARM translation tools. But sometimes, even with ARM translation tools, the application won't run properly. So I'm sure that at this time, you may have gotten back to the real device plugged to the computer. And it can really become very expensive for your company if it needs to buy a phone for everyone. It is still manageable for developing applications, but for scaling tests, it can become much more expensive. But this is changing, and for a few years, ARM-based computers and cloud servers are arriving on the market. And Oracle Cloud is following this trend by releasing ARM servers. And thank you, Robert, for giving us a lot of information regarding this at the beginning of this webinar. And we see that since last year, the number of these devices keep increasing rapidly. In the Android under development world, there are a lot of people who are using Mac computers, and we also see that Apple shifting to ARM for its Mac computers is certainly accelerating the spread of ARM computers. And with ARM-based emulators available on ARM cloud servers, we can finally test on the same tool chain and architecture of a real device. So no more ARM translation tools needed to be installed on the emulator, and testing native code becomes really easy. And all the steps in the mobile lifecycle can be done on the same architecture of a real device. And testing Android mobile application ARM devices is one of the many tools used for mobile testing, and it is really important to conduct those tests properly. In your company, you may have been using agile methodology to develop and deliver your mobile application. So which means that you build, test, and deploy more often than before. And if you are a QA engineer, you may have already been more and more involved, and you must have a key role on the application quality. We all know that an application failing to respond has a direct business impact. And we see that more and more QA managers are adopting a shiftless strategy. They conduct tests early to minimize the cost of bugs. So tests need to be automated, leaving manual testing for exploratory tests. Automating tests is not enough. Having a good strategy is the key. And the key components of this strategy are choosing the most suited testing framework, the tools around the automation, and also how those tests are being run. And here are some examples of implementations where automating tests without any strategy is inefficient. For example, you have application for both Android and iOS, and these needs to be tested. You choose two different testing framework, Espresso for Android, Anpium for iOS, although you could choose Anpium for both and have common testing code for both application versions. Other examples, automating tests without any continuous integration environment, or automating tests in several batches without any parallelization. All these will add more testing time to your testing strategy. We will now go into more details on the tools for Android mobile automated testing, and I will hand this to Thomas.
Thanks, Elino. So before talking about testing framework, I'm going to do a little reminder on the continuous integration workflow. I think that most of you know how it works. Developers push their code into a source control server, for example, GitHub, GitLab, and the CI, Jenkins, Circle CI, etc., will detect the change and it will trigger some jobs, build, test, deploy. And when it's done, the result of the jobs will be notified to the developers and testers. So let's talk about testing framework. The most used testing framework for Android mobile tests are Espresso, Anpium, and Detox. All of them are able to test native and hybrid application. Anpium can also test web apps, and Detox is known for testing React Native application. Espresso is essentially used by developers because Espresso needs to have access to the source code. It's used only on Android, and you can write your code on with a Java or Kotlin language. Anpium and Detox philosophy is to test as a real user. They are most used by testers because they don't need to have access to the source code. And another advantage is that they are used to run tests on Android and iOS with the same script. Let's discover Espresso architecture. Espresso testing allows developers to build a test suite as a standalone APK. This APK can be installed on the target devices alongside the application under test and be executed very quickly. Espresso does not require any server to communicate with. Instead, it's run side by side with the app, with the application, and delivers very fast test results to the developers. Now, let's talk about Anpium architecture. Anpium is an HTTP server that is written on a Node.js platform. It works on a client-server architecture, and Anpium allows the use of the available WebDriver client for executing tests. That means you have a lot of WebDriver client for any language, like Python, Java, JavaScript, Go, etc., etc. So the Anpium server receives the connection from the client side, listens to the command, executes the command on a mobile devices, and it returns the command execution status as a HTTP response to the client. And the last one is Detox. So there is a Detox server that communicates with a test suite running on Node.js using a test runner like Jest or Mocha. It executes the user commands sent by the tester with WebSockets, and we launch them on the mobile application. A regular native build of the application is installed and executed on the devices. So we have talked about testing framework. I will let Elinor explain where to run your test.
Thanks a lot, Thomas. Yes, we know how to choose the most suited testing framework. Now let's talk about the tools used to run those tests, and one of them are the continuous integration servers. These servers play a central role in the mobile development application lifecycle as the orchestrator of building the application, starting the devices, and running the tests. There's a tendency for cloud solutions because it is easy to set up, the infrastructure is managed for you. As we all know that it can be really time consuming to configure all these on-premise if there aren't any experts in your company to do that. There are several continuous integration servers out there. Some of those CI servers are Bitrise, which has a user-friendly interface to create job workflows, which is quite intuitive, ideal for people that are not very familiar with creating jobs with configuration files. But if you prefer configuring jobs with files, you can do it with a YAML file. With other CIs are Secure CI, GitHub Action. They are both available as cloud or on-prem. And the jobs can be configured from a YAML file. So once you have chosen your testing framework, written your tests, and chosen continuous integration server to run those tests, you need to choose on which type of devices to run them. What we often see is that people are using a hybrid approach by using physical and virtual devices. And why? Because they are complementary and have both pros and cons. So what we see is that for daily tests, people tend to use virtual devices. Indeed, we can use APIs to test the application in various conditions. For example, doing image injection, which could be hard with physical devices. As we test often, we need to be really reactive and have devices always available for the test in order not to block pull requests. We also see that there is a tendency to move to the cloud to avoid all the hassle of managing the infrastructure and achieve better scalability. And having ARM emulators available on ARM cloud servers helps scaling the tests. But we know that with virtual devices, we can't test everything, and especially the device manufacturer's specific layer. So usually real devices are used before a new release for full validation. I was talking about ARM emulators earlier, and Genymotion device image is one example of a Cloud-Arm-based Android emulator, which is available on Oracle Cloud. You can interact with an Android device manually from a web browser for exploratory testing, for example, or automatically when a continuous integration job triggers the start of the devices and runs the test on it. And as it is on the cloud, the number of devices can be easily scaled up and down to achieve better scalability and reduce your testing time. And Thomas will talk more about it later in the presentation. And also, as you can connect to Genymotion Cloud devices directly with an ADB connection, the integration is quite seamless. You run your tests as if you had physical devices plugged to your CI. You have now all the tools to build your Android testing strategy. So let's talk about how you can reduce your testing time by parallelizing tests to better test at scale. And for that, I will hand this to Thomas.
Thanks, Elena. So why we need to run tests at scale? First, to improve the test build time, and you will get the result as soon as possible. It allows you to test your application with the same or different Android version. I think you all know that functional tests can take a long time, depending on the number of tests you have, depending on the number of Android version you want to test. It can be annoying to wait for the result. That's why we encourage developers and testers to scale their tests using parallel testing or test sharding method. Let's talk about parallel testing. Imagine you want to run your test on several Android versions, Android 8, 9, 10, 11. The goal is to start several devices at the same time and run tests on all of them. The benefit of it is you will improve your test coverage, and you will be sure that all your scenario will work on all Android version you target. It can be useful to run tests in parallel before a release. Parallel testing is easy to set up with almost all testing framework using library like PyTest for Python or TestNG for Java. About test sharding, the purpose here is doing test sharding is to spread tests across devices and ease the testing workload so, that you can execute automated tests faster. Imagine that you have 100 tests taking 10 minutes in total to complete on a single devices. Now, what if we divide these 100 tests to get then run on 5 devices, 20 tests for each devices? It will take 2 minutes rather than 10 minutes to finish the test session and get the test report. This method can be useful when development is still in progress and you want to catch bug earlier. For example, when you push a pull request or a commit. You don't need to run those tests on each Android version, but you want to be sure that they are working. Test sharding is also easy to set up. You can use Android instrumentation runner or Spoon for Android. So we hope that you all now have a good overview on the tools and advantage on running your Android mobile test on ARM. So to conclude this presentation, we will perform a demo to show you the two-test method. So before the webinar, I've started 5 Genymotion instances on the Oracle Cloud Platform. To start them, I've used Terraform. Terraform is infrastructure test as a code tools. It allows you to create and manage your cloud infrastructure using a simple configuration file. It is really helpful when you want to create the same mobile test infrastructure to be sure that your tests will run on the same configuration each time. I can show you a simple Terraform file. You need to provide to configure the provider. You need to declare resources. For example, here is a OCI core instances. You can specify the number of instances you want to start. You need to configure some details like the virtual network configuration. You can specify a name. You can add some metadata like the SSH key. You can also configure the shape configuration to define the CPU and the memory. And after that, it's required, you need to provide the OCI image name, image ID. So I've started them. So for this demo, I've also created an HTML page using our Genymotion device player JavaScript SDK. It provides an easy way to integrate Genymotion devices running in the cloud into any web application. You will be able to display an emulator screen and interact with the devices. If you want to see what's happened on your devices during the test execution, it's easy to set up. For example, here I have an Android screen. I can interact with it, with all the instances. I've also created a simple demo application and write some tests. I can show you the application. So the application has 5 buttons, and each button trigger an action. For example, action 1, display a text. Action 2, display an image, etc., etc. So the test will click on each button and check if the elements are correctly displayed. So now I have my Android instances started. I've also connected them through ADB in order to let Anpium interact with the instances during the test execution. As we said during the presentation, as it's connected with ADB, the integration with all testing framework and testing tool is quite seamless. So if I do ADB devices, I hope it's good for the. So here I have my 5 Android instances connected to my computer. I'm using Anpium, so I will start Anpium server. And I will perform a test in parallel. So we will run all tests on all devices. And after, I will test the tail sharding. So I just need to configure PyTest to run my test on each instances. So if I just run PyTest, I will try to display the page. So it would take a few seconds to set up Anpium on the instances, and after we will see the application, and we will see that all tests, all action are triggered in all instances. So as you can see, each device displays the text, and after it will display yes, okay, the image, etc., etc. So it will take few seconds. So we just need to wait. It's a good example because after this presentation, we will try test sharding, and we will see that it's you will get the result faster. Here we have 5 tests per devices, so 25 tests in total to complete the test execution. So it's too long. When you want to have when the development is in progress, you don't need to wait all this time. So as we see, 25 tests passed in 1 minute and 15 seconds. So now let's try with test sharding. Just need to configure PyTest with a load argument and with test sharding. So the PyTest will dispatch all tests on all instances to run test once. So let's try. So as you can see, one instance, one test. And you get the result in 25 seconds. When it's done, you need to stop instances also using a destroy command from Terraform. Here I use my computer, but as it's a script, you can easy set up this demo on any integration server. So that's all for the demo. So I will let Elinor to conclude this webinar.
No, thank you, Thomas. Can you go on the next slide, please?
Yes, sorry.
Yeah, terrific. So yeah, I think that Tara already shared the link to sign up. So don't hesitate to try Genymotion on Oracle Cloud. In the follow-up emails, we will also send the sample code from the demo so that you can also try out if you want. Yeah, can you go on the next slide, please? So these are additional resources. Of course, the presentation will be shared so that you can have access to all these links.
Well, thanks, everybody. That was great. I really appreciate everybody's time. And we will, this webinar will be made available shortly after we close out today. Thank you again.
Thank you.
Thank you.